Hello, my name is Jonathan Coe. I'm from Respiratory Therapy. Today I'm going to go over the Hamilton T1 Transport Ventilator. The Hamilton T1 Transport Ventilator has a touchscreen as well as a soft key and a dual rotary knob for its functions. To go around this vent on the outside, it does have a handle that you can tether to. It has the strap, but I wouldn't secure your Hamilton T1 ventilator with this strap. On the back side, it does have hooks, and I'll rotate it around in a second, that you can hook it to something, and then this strap can then secure around the apparatus or equipment. So that way when you hit a bump, it doesn't come off of the rails. I'm going to rotate this to the side. The first side you'll see right here has your power cord organizer. It is a regular plug, no specialty plug, and it enters the ventilator through this port right here. Okay. It only has one gas connection, which is the oxygen connection here. It entrains its own air through the ventilator, so you do not need to plug in an air hose. If you do have a patient on room air, you do not have to plug in the O2 line unless you're expecting to use an O2 breath. Otherwise, you can run it on room air if you're trying to conserve oxygen. To rotate this around again, on the back, you'll notice the hooks that we mentioned earlier. You can hook this to a stretcher rail, but use the little leather strap to go over the rail, so that way when you hit a bump, it does not come off the rails itself. Where it entrains the room air is through this air inlet labeled air. You'll notice it's got a removable filter right here. If it does get visibly soiled and dirty, you may try to clean it out or replace it. It just goes in that little slot in there to replace. Okay, these air filters do not need to be replaced every single time you use it. You can replace it when it's visibly soiled or during the routine PM on the vent itself. Be aware that if the alarm if the ventilator does alarm low air, it's usually because this is covered up typically by a bed sheet. So be cognizant of that if you do see that message. Otherwise, it'll try to pull in as much air through the void as possible. Now I'm going to flip all the way around to the other side. And this is the business end where you'll do most of your work on. This is where you'll connect your ventilator circuit and tubing. So on this ventilator, you do have several different options and features that are extras that you may get either with the ventilator you guys have ordered or as an add-on option at a later time. So this ventilator has the capability of doing CO2, which is a plug port connector. If you do not have the CO2 capability on your transport vent, you may use your regular N-Tidal CO2 system that you're currently using. It does have the ability to slave to a monitor and to nurse call. Down here you'll see 3 ports. These are for the flow sensor ports, and the top one is for your nebulizer port, which the nebulizer port you will not be using. We will be utilizing the Aerogen system that you're currently using right now. At top here, this is the inspiratory side of the ventilator. This is where the machine will push the air out to the patient. On the bottom is the expiratory side. Okay, so let's get this set up. up until this point, everything does not come apart. So when you go on a transport and you come back, all you do is wipe it down with a hospital-approved cleaner per the manufacturer's dwell time, and it's good to go. Everything after this point, so the ventilator circuit and the exhalation valve will be tossed. Okay. So to start the setup, you will need an expiratory valve kit. It comes in its own kit itself. Looks something like this. Okay. What you're going to do is remove the cap. So on the side of the expiratory valve, it says remove before use. You want to take that cap off. Be very aware that there is a silicone valve right underneath that cap, and sometimes when you squeeze that cap too hard when you're taking it off, the silicone valve does come off. All you do is line it up with this notch down at the bottom with the corresponding notch on your valve. Put them back together, make sure it's properly seated, and then you're good to go. The other side here is another piece of plastic, and this is where it locks onto the machine. So do not remove this piece. It's got claws that are hooking onto the expiratory valve, so it'll be very, very hard to remove unless you're intentionally trying to take it off. Alright, so let's put this into the ventilator. So as we mentioned, there's a notch down here at the very bottom of the expiratory valve. There's also a notch that's inside the ventilator itself. Line up that notch. And as you get good at doing this, you can do it pretty much blind, just by feel. So once you put it in, find the notch. What you want to do is do a quarter turn, and you'll feel it click. Once you feel it click, or it doesn't turn any further, it is secured into the ventilator. And you can double check by trying to pull it out. If it doesn't come out, it's properly seated inside. The next thing we'll need to do is add our viral bacterial filters. You can use any viral bacterial filters. You'll need one on the expiratory side, and if you're using the Hamilton circuit, you'll also need one for the inhalation side as well, unless you want to cut a piece of tubing to fit the length of the elbow on the Hamilton circuit. And you'll see in a second what I mean. You'll definitely need one, a filter on the expiratory side, and the reason for that is the exhalation from the patient comes out from the bottom of your exhalation valve. Okay, so this is not only to protect the ventilator, but it is to protect yourself as well from anything that the patient has. Okay. All right. If you're using the Hamilton circuit, it comes in a kit. It looks something like this. It's a single limb dual lumen circuit. By that I mean it has the inspiratory and the exhalation inside one single tube. And if you're using the Hamilton circuit, it will include a flow sensor, which is this darker blue piece at the top. If you're using a non-Hamilton circuit, which you can do, you would have to buy or get a flow sensor separately. What you'll notice in the kit too is there is an adapter. This adapter sometimes comes off when you open up the package. Make sure you try to keep it intact. It's usually clipped at the top right next to the flow sensor. This piece is only used during calibration. If you lose this piece, you do not need to open up another piece, and I'll show you how to do it without the adapter once we get to calibrating the system. As I mentioned before, reason why you need to have two filters on the vent or have a 6" or have an extension tubing cut is because on the Hamilton circuit it has a hard rigid elbow, so if you do not have another filter, it will not reach into the ventilator itself to connect. The circuit can be put on either this way or this way. There is no difference each side. It's just the flow will be traveling through the different lumens in the circuit. Typically, we have the circuit facing towards the front of the ventilator, like so. The next thing you want to do is connect your flow sensor to the ventilator. What you'll notice is your flow sensor, the little tubes, you got the blue and the clear tube. You want to make sure it's going towards the ventilator itself and not the opposite way around. So what you'll do is you'll connect your blue to your blue port on the machine, and then you'll connect your clear port to the other connector. The nebulizer port, you'll notice, is slightly bigger, so the flow sensor tubing will not fit on the nebulizer port. And now you're set. Hamilton circuits come in either a 6-foot length or a 9-foot length circuit. Either circuit hooks up the same way. Now that our ventilator circuit is set up, I'm going to flip this around so you can see the front of the ventilator. If you're adding dead space, such as a HME, Ballard, or a nebulizer in the circuit, you can calculate your dead space during your calibration by putting them in line with the circuit during your calibration. So for example, if I were going to use an HME, I would hook it all up in line and then stick the flow sensor at the very end. You will need an adapter to get this to fit. And then when the machine does its pre-use check, it will account for what you have in line here. Now after it's done doing the pre-use check, you can reconfigure your ventilator circuit to the proper way of assembling, or the standardized way of assembling your setup before patient use. Okay, so some troubleshooting tips from someone who's been using the Hamilton system for quite a while now is when you're ventilating a patient, be very cognizant of how you place the flow sensor. You'll notice the two tubes on the flow sensor. You want to try to keep these upright. Otherwise, if you have them inadvertently turned upside down, moisture or condensation can get trapped inside these tubes, and then that will render your flow sensor useless. So try to keep this upright so that way gravity is your friend. So it decreases your chances of getting micro bubbles inside your flow sensor tube. If by chance you do get condensation or water droplets inside your flow sensor tube, what you can do if you're ventilating a patient, is disconnect the flow sensor from your circuit, hook this back up to your ET tube. So put the ventilator circuit back onto your ET tube, take the flow sensor out of line, disconnect the micro tubes from the side of the ventilator, and what you're going to do is to get a 10 cc syringe or something similar, stick it in the end of the microtubing. So you're going to flush it back towards the flow sensor itself. Okay? So what you're going to do is you're going to put the syringe on this end, and you're going to blow air to try to push whatever is stuck in your flow sensor back out of the sensor again. That may sometimes save you from having to open up another kit to get your flow sensor, or try to find another flow sensor itself. And after you're done, basically reconnect the flow sensor back onto your vent circuit and back onto your patient again. For this purpose, I'm just going to use a straight flow sensor and no HME, but like I explained before, you can have it all set up, and when you do the calibration, it'll all account for it. So I'm going to power this up. To power it up, you hit the power button, hold it for 3 seconds, and you'll hear it kind of make some clicking sounds, and that rotary knob will also light up as well. It's doing its kind of a self-check right now, and then it'll go to its home screen. While it's doing that, just to cover some more information about this ventilator down at the bottom panel has a pull tab right here at the bottom left hand side. If you pull that out, this is where your battery live inside this ventilator. So it has one battery that is permanently fixed to the ventilator itself. If you want to remove it, you have to get a screwdriver to take it out. It has the capability of having a second optional battery to extend the runtime of this vent. So now the ventilator has powered up. This is the home screen that it comes to. What you need to do first before you do it before you put it on a patient is you want to do a pre-use calibration. To get to that menu, what you're going to do is hit this pre-op check button down here at the bottom left hand corner of the home screen. It'll take you to the test and calibration menu. You'll notice there's 3 options on the screen. There's a tightness option, a flow sensor option, and an O2 cell option. You do not need to do the O2 cell option, but you do need to do the first 2, the tightness and the flow sensor, before you use it on a patient. If you're concerned for time, or you have your workflow so that you do this when you're coming on your shift, what you can do is do your calibration ahead of time and then leave it on standby. It'll save your calibration on the ventilator until you're ready for use. An important note is that you can still use the ventilator if you haven't done the pre-use calibration. So if you're doing back-to-back road trips or transports and you do not have the time to do the calibration again, it will still run. However, it will reuse the calibration data from the previous calibration that it performed. So just to keep in mind, it is strongly recommended that you do a calibration prior to each use, as the circuits may be a little bit different depending on if you're using the same circuit, which the difference may be very little, to if you're using a different circuit altogether, in which the calibration measurements may be different. Reason you do the calibrations is so that way when you're running the vent, the measured and the output will be accurate to what your patient is doing. So your volumes and your pressures and your resistance and compliance will all be accurate. All right, so we're going to start with the pre-use check. So we're going to start with the tightness. So make sure you're following the prompts on the screen. The prompts are located down below the bar right here. So now I'm going to tighten the circuit. And what it's doing is checking for compressible volume in this circuit. Okay. When you completed, either pass or fail. If you pass, you'll get this green check mark. If you fail, you'll get a red X. It'll timestamp when it was last done. So if you come across a ventilator and you don't know if it's been calibrated or not, and it has a circuit hanging off of it, you can pull up this test and calibration menu and it'll tell you when it was last done. So that was it with the tightness check. So we'll move on to the flow sensor test. For the flow sensor test, you do not need the cap, so you can discard the cap. If you still have your adapter from the kit, this is where it comes in handy. So you're going to stick it on the end of the flow sensor, like so. When the message tells you to turn the flow sensor around, you're going to flip it around, and it fits snugly into the circuit. If you do not have this adapter, what you'll need to do when it tells you to flip the flow sensor around is hold the flow sensor up tightly against the ventilator circuit, like so, until the duration of the test is over, or when the message tells you to flip it back around again. I'm going to demonstrate it with using the adapter. So we'll go ahead and start up this test. So disconnect from the patient, turn flow sensor, and then what it's doing is essentially it's shooting out flow through the circuit, and then it's measuring how much it's putting out versus what it's measuring up against. So that's how it calculates the flow sensor. As the flow sensor is going through the test, you'll notice it starts winding up louder and louder. Now it's wanting me to turn the flow sensor around. As long as you perform the prompts within a few seconds of the message coming on, it will continue with the test. If you fail, let's say you get distracted, when the message prompt changes, it will fail your test and you have to start all over again. In my experience, the test that usually fails for people is the flow sensor test, and that's usually user error. It's usually because they don't have the tubes connected tightly to the ventilator, or they didn't follow the prompts closely enough, or as they're doing the calibration, they're walking around or shaking the tube, adding some extra flow into the circuit, and that's causing them to fail. So try to hold the circuit still while you're doing the flow sensor test, and you should be able to pass this majority almost all the time. Those are the two pre-use calibration checks you have to do prior to placing it on a patient. They're fairly short and does not take a lot of time. And the other thing when you're doing your pre-use check is it does not require you to connect the ventilator to any gas source. So actually entrain room air when it's doing this calibration. I'm going to go back a little bit and go over these soft keys. The big green one at the top is the power button. One to the left, or to the right of the ventilator here, is a daytime nighttime button. To the left of that is a lock on and off, and as these functions are activated, there'll be a green light next to the soft key itself to let you know it's been turned on or off. Okay. Below that, you have a lung icon. That lung icon is to allow the user to provide a manual breath to the patient. Next to that is a arrow pointing up with an O2 next to it. So if you push this button, it gives you 2 minutes of 100% oxygen automatically, as long as your oxygen hose is connected. After the 2 minutes, it will revert back to the previous setting or the default setting. If you want to cancel it prematurely before the 2 minutes are up, you can hit that again and it'll deactivate the 100% oxygen. Below that, you do have a kind of looking like a printer icon. This is to allow for screenshots or to export data such as training or education through a USB port located on the side by the power cord organizer. Next to that button, you do have a nebulizer button, which we will not be utilizing. Below everything will be your alarm silence button. It gives you 2 solid minutes of alarm silence. The lights will still be flashing, you'll still be getting the messages, but it'll silence the alarm for you. One advantage of this ventilator is that as it's alarming, you're not locked out of the ventilator. You can still make changes with the ventilator as it's alarming. You do not have to hit the silence first before making changes. This is a rotary knob, so it twists and turns and also clicks. So when you're making changes, you can either confirm with the knob or on the screen. This is a double confirmation ventilator. By that I mean to make every change, you do have to confirm your change twice. For example, if I want to change the oxygen percentage on this vent, I click the oxygen icon on the screen. It'll go from blue to orange. Make my adjustment. For this, I'm going to turn it down to 21%. You can hit the screen again and it'll confirm your change, or you can tap the knob and it'll confirm the change. One thing to note, if you're ever wondering what the maximum and minimum of a setting is, you can click on that setting and it'll give you a scale, low to high, and that'll tell you what your capabilities of that setting is on this ventilator. This ventilator also allows you to go back and see the events from your last patient. To do that, you can hit the last patient button, you can hit the events tab down at the bottom, and it'll pull up all the events that occurred with your last patient transport. This is a one-in, one-out system. So as soon as you start this ventilator on another patient, it'll start dumping the data from your previous patient. Hit the X button to exit out of that pop-up menu or pop-up box. What you'll notice down here on this home screen also is the ideal body weight. It can calculate for you as long as you have your height in inches, or you can have this configured to be in centimeters as well. So, for example, like so. So a 54 kilo male or 54 inch male would be 36 kilos of ideal body weight. Okay. This does have capabilities of neonatal, adult peds, depending on what your ventilator comes with. it'll have the corresponding stickers down at the bottom to let you know what's been preloaded on this ventilator. If your ventilator does not come preloaded with the neonatal feature, then the neonatal tab will not be there. Alright. Under adult peds, which most of the time Aircare Mobile Care will be using, it gives you 3 default presets. So you got adult 1, 2, and 3. You can configure each of those presets so that it shows a certain mode or certain setting number that you want to appear when you first turn on the ventilator or when you flip to that preset. The other thing is with the ideal body weight, right now it does not correspond to your tidal volume. However, if you do want to later in the future, you can have it set so that way it displays a certain mils per kilo based on your ideal body weight. It is most useful in the ASV mode, which is currently preset from the factory, and ASV is a proprietary mode to Hamilton Medical. So unless you're receiving a patient from another hospital on a Hamilton ventilator, you will not see this mode being used. ASV is a smart ventilating mode similar to SI&V, which we will not be covering as the use of this is fairly small around the United States right now.